We're going to measure the IV curves, as they're called, of various electrical components. That's a graph showing the voltage or potential difference against the current for various components. Very simple experiment. Here's the circuit we're going to use. We have a variable power supply of some kind, so we can turn the potential difference up and down. We have an ammeter for the current. Here's electrical component in series. We have a voltmeter across it, and then by getting varying voltages of voltage and current, we can plot a graph. Our axes are very simple. We have positive potential difference, positive voltage, positive current in this section, negative values here, and that way we'll see simple IV curves for various components, and we can see the differences of how they react. We'll look at an ohmic resistor, we'll look at a filament lamp, and we're going to look at a diode. Three very different components. So, this is the simple setup we'll be using. Power supply, a very simple series circuit through our components. So here's your series circuit with your ammeter reading the current, a voltmeter across the component. We have our ohmic resistor in the circuit at the moment, and by turning up the voltage we can get positive readings. Then if you want to get negative readings, we can swap these over and then get negative readings, so we can sort of see that they behave the same, positive and negative. The components we've used today, we're going to use today, are the filament lamp, which is our sort of our grey boxes, and here's a diode that we're going to use as well. So we can plot it on a graph directly on the screen and show you what's happening rather than you record all these values. We're going to actually, when I do this, replace the 2 meters we've got here with data logging equipment. Here's the current sensor, that will be our ammeter, this will be our voltmeter, and they're both connected, as you can see here, to the laptop computer. And so with the laptop computer we can record on the screen what we're going to see. So there's the setup. Let's get started, shall we? Okay, so we're now going to record the IV curve for an ohmic resistor. We will start at a high voltage, then drop it down to a low voltage, then reverse the connections to get the negative values. So let's see what we get. So I'm going to drop the voltage slowly down. Here we see we're approaching a pretty good straight line down towards the origin. And as we should, we need to do negative values. So I'll swap the connections over now and then go the opposite way. And there you'll see, I think we can agree, that is a pretty good straight line. Okay, so we're now going to do the IV curve for a filament lamp using the same equipment as for the ohmic resistor. Again, we'll start at the high voltage setting. There's a good reason for this. The equipment does sometimes give a little glitch if you go the other way. Most odd. So, shall we get started? Yes, we shall. Okay, so let's start reducing the voltage down from where we started. Here we come, it appears to be a straight line. Not quite pointing at the origin, but then you can definitely see that seems to be curving towards the origin. So I'll now swap the connections around and go the opposite way, and this is where we get the glitches when you're going up sometimes. Getting higher voltages around about here. If it goes slow enough, you avoid it. You can see a bit of a wobble on the graph there. That's the nature of the equipment, not the experiment. And there we are. You can see the complete graph, despite that sort of slight glitch. The glitch appears when the bulb starts to glow. If you start when it is glowing and move down, you get a smooth curve. If you go from when it isn't glowing to when it is, you get a wobble. I'm afraid that's part of the equipment. But, as we can see, very distinct shape in the positive values. The negative values is a repeat of the positive values with just a little wobbly line in one or two places. Okay, so now we're going to do the IV curve for a diode. It's very different to the other traces, really is quite different indeed. So we're going to, I'll just connect the circuit up on this side here, and let's get started. So, you can see there's a negative voltage. I'm starting very negative, slowly moving up. There's not a lot happening with the current at all. No real current flowing through, as we can see. I'll now swap the connections over and try positive values. See if we see something different for positive. And here we go for the positive values. Still not a lot happening at all, really. Not a lot happening at all. Oh, just starting here. Here it goes. Going quite sharply now. I have to be careful not to burn the diode out. Quite sharply up. 0.7, 0.8, 0.9. That is really quite clear what we've got there. Okay, so as a final summary of what we've learned today, I've drawn all three component graphs. This time you'll notice I've drawn the potential difference for voltage on each one on the same axis, on the x-axis for consistency. You're supposed to recognise each of these components and knows what it is from looking at the graph. They're very distinct, very clear. So obviously, ohmic conductor, straight line, constant resistance. Your filament lamp, which has got increasing resistance as it gets hotter, so it's the temperature that's causing the effect. Now, when I had the axis the other way around, the graph curved that way, the gradient was the resistance. It's the inverse of resistance this time. And then our diode, of course, where we've got very, very high resistance and suddenly switches to very low resistance at a certain voltage. So, that's the components you need to know, and I hope you found this video informative and interesting.